Okay, back to the valve covers. A lot of people like to upgrade these to turbos or aluminum. They are stronger, they last longer from warping, but I've yet to see any valve cover of any 911 not warp. And what happens is, when you pull these gaskets off, they get wavy from people over tightening at one end, loosening, and it just warps it. So what we're going to do is belt sand these. They'll be nice and flat. We even belt sand the turbos, but if the customer wants the best cover made, the aluminum ones are better and the turbo ones are better. These are fine. They'll be machined. They'll be good as new. But again, we also have another mix. This is magnesium, this is aluminum. This one doesn't have a 930 part number, but you can tell the difference in color. Shiny silver, shiny gray. So this motor was kind of put together in parts, and we're definitely going to show some more that proves that point. These are your lower, these are your upper. They're both magnesium, that dull gray. Move these here. And move on to the chain boxes. Again, this is just a quick checkout visual. Chain boxes are off of 1974. You can tell right here by this circle. Some will say 1 of 74, which is January 74. This is 74. So that's a 74 housing. The motor serial numbers is a 75, so that's about right. And this one here is a 74. So yeah, these are the matched brother and sister, so that's good. Looking over this, you definitely, you know, a little dirty. There's still a lot of silicone built up inside. So we're going to mic these out and check them to make sure that these boards aren't all screwed up of coming apart or over tightening and they're gouged where it's going to leak. We never use RSR seals. A lot of people sell those. If you do the shafts right, shafts go into the boards here. Little seals go here. A lot of people use them as insurance, but if these are done right, centered properly, tightened properly, then after about 1,000 miles of break-in, check them again, they don't leak. And if the boards are prepped right, these are prepped right, they don't leak, you don't need the seals. And we've seen the seals sometimes put a little bit out of pressure to snap these right here at the edges. So what happens, you tighten this starts squeezing, these outer shoulders dig in, they press out into the bore for it will not move. It's our oil cooler, just doing a visual. We're going to pressure test this, bolt our plate up here, hit it with some pressure, see how she holds. You know, a little dirty, a little messy, but hey, it's a cooler. It does its job. That's all we care about. For the piston cylinders, this motor's about 30 years old. You can tell it's not. They're not too old. A lot of busted fins. This motor had a big problem on its head studs being installed. They didn't use a jig. We're going to show this in a minute on the case, but the studs, instead of going straight out evenly, they were porcupine. Because they didn't case over the block, they actually put Healy coils with a drill, so instead of the studs being straight, they were like this, which we're digging into here, which when you try to get off, breaks fins. These are cooling fins. A couple broken actually. Doesn't look pretty, but will still work since turbos, they actually machine these all off and just run one side. You know, but for visual, it's nice to take care of these. Don't break them off. Pistons, these have been replaced. These aren't the original pistons. But this car had a major fuel problem. How we know that is, the cylinders look really pretty inside. And these are Nicosil. They're magnetic. They're not Alusil, which we work with both. The cylinders look so good. The pistons ring glands right here are beat out. What happened is the gas has been washing the rings, letting the rings flutter, and it's beat this top ring gland. So that top ring gland is beat out. Protected the cylinders, but beat the pistons up. So that's not cool. So we're going to mic everything and see how it looks. We'll go to the next stage in a minute.